Hey guys, do you guys hungry? Want to grab some snacks?
I'm also hungry and I want some snack. But first, let me finish my homework. How about you, Wan?
Alright, I just follow you guys. Okay guys, I just done buying my snack.
Oh, you also buy same type of like us, snack?
Yeah. What do you guys buy?
So I buy 2 water bottle, 2 biscuit and 2 pack of coffee for 8 ringgit. How about you guys?
I bought 3 bottles of water, 1 biscuit and 4 packet of coffee for RM9.50.
So cheap I buy this for 10 ringgit. So I bought 2 bottle, so 3 biscuit and 2 packet of coffee.
Wait, we have the same amount of coffee, but why mine was cheaper than yours?
Remember I have 3 pack of biscuit and you have 2 pack of biscuit.
Oh, so have you wondered how much for 1 biscuit? I don't remember.
I don't know.
I'm also wondered how much it costs for each type of this food. I think we need to solve this problem.
I think we might need some help. How about you call Akif? He's smart at math.
I also think like that. We need some help to solve this problem. Let me call Akif.
Oh,
What did you do?
yeah, I'm having massage now.
Do you have free time?
Why do you call?
We need your help to solve this problem.
Oh, you need my help? I see. Okay. Okay, later I will help you. Wait wait
Oh, okay.
So Judin, Wan and Afiq have a problem. And we need to help them. So the item that they bought are biscuit, coffee, and water bottles. So now we're gonna let all the items to become biscuit as X1, coffee as X2, and water bottle as X3. Now that we have made that, let's solve the problem.
After letting all the things that they bought with a variable, we can get an equation based on what they bought. For Hafizuddin, we can get an equation x1 plus 4x2 plus 3x3 equals to 9 ringgit and 5 cents. Based on Afiq, we can get 2x1 plus 2x2 plus 2x3 equal to 8 ringgit. And based on what one bought, we can get an equation 3x1 plus 2x2 plus 2x3 equal to 10 ringgit. And well, after we get all the quadratic equations, we can make it into the matrix form. We can create a matrix like 1, 4, 3, 2, 2, 2, 3, 2, 2, and a vertical bar. We put uh, the coefficients with a bar. We make a matrix form out of it. So now, with this matrix, to get all the unknowns, we're gonna use the Gauss-Jordan elimination method. We are required to change all of these 3 numbers and these 3 numbers into a 0. And we also need to change all of these diagonal numbers to 1. So now, let's start. The first equation that we are required to do is we need to change these numbers, these columns to 0. By using the leading one, we can make an equations negative 3 R1 plus R3 and 2 R1 plus R2. As you can see, we can use, we need, as you can see, negative 3 R1, we substitute 1, and then we plus the numbers in about 3, which we will get 0. And the second equation, as you can see, negative 2 R1, we substitute the leading one, the row 1, and we plus with R2, which is the number in row 2, which is 2, and we get 0. So now we need to do the same in the other column, which we will get the first column, we will not change anything because we are using the leading one in the first column. So we will get, after substitute the row 1 in the equation, we will get negative 6, negative 4, negative 10, negative 7. We need to do the same for the coefficients, which is we will get negative 11 and negative 8.5. Well, now we are making progress because now, as you can see, this column has already turned 0. So the next step is we need to multiply by negative 1 over 6 with the second row. And we will get the second row to become 1, 0, 1, and 2 over 3. We can just copy the first row and the third row because this equation will not interrupt any of the numbers. So we can copy 1, 4, 3, 0, negative 10, negative 7, and the coefficients we need to also for the negative 11 we need to also substitute in the equation, and we will get 11 over 6. Let's copy the answer because it will not disturb by the equation. Next, after we got our leading one, we need to change the numbers below it to 0. So we can do that by substitute the numbers in the equation. Then R2 plus R3, which it will only disturb the row 3, and we will get the answer 1, 4, 3. I will just copy for the first row, and also the second row. Just copy because it will not disturb the equation, will not disturb the first and second row. But the third row, we will get 1 over 3 by substitute the row 2 numbers into the equation. The coefficient we get 9.5, 11 over 6, negative 1 over 6. Okay, the last one, we need to do the same things in the third row. We need to change this into a leading one. So the way we can do that, we can substitute row 3 numbers into equation negative 3R3. Get the answer 1, 4, 3. The first row we can just copy, and the second row also we can copy because it will not disturb. And the third row it will become 0, 0, 1. And the coefficient we will get 1.5, 11 over 6, and 0.5. At this step, we already got our diagonal leading one, and also all of these 3 numbers are 0. After having this part of matrix like this, we can get the third unknown, which is x3 equals to 0.5. After getting this unknown, we can solve the 2 equations, which we call this the Gauss method, to get the answer. But we don't want to do that. We want to do the Gauss elimination methods. So we need to reduce all of this to RREM form. Then we will get the coefficient, the answers. So now we will continue reducing it to the RREM. So by doing that, we need to change all of these three numbers also to 0. So next equations, we need to change these numbers to 0. We can use the equations negative R2 plus R1. So we get the answer 1, 0, 1 over 3, 0, sorry. The next step is we need to change these numbers to 0 as well. You can do that by substitute them into the equation 2 over negative 2 over 3 R3 plus R2 and negative 1 over 3 R3 plus R1. So then by substitute the first row into this equation and the second row into this equation, you can get the RREM of the matrix. We need to also substitute the coefficient into the equation, which we will get our final answer is 2, 1.5 and 0.5. With that, we get the answer x1 equals to 2 ringgit and x2 equals to 1.5 ringgit and x3 equals to 0.5 ringgit or 50 cents. So that's it. We have solved the problems. Let's tell Hafizuddin and friends about the answer.
See, it is very easy to solve unknown with Gauss-Jordan elimination method. So now, let's tell Judin about the answer. Hello. I sent you the answer already. Look it up. Okay.
From the answer that Akif gave me, so I know that this biscuit costs 2 ringgit and this coffee costs 1 ringgit 50 cents, and also for this water it only costs 50 cents. Now we know. So thank you to Akif because he solved our problem.
Wait, what the method did Akif use?
He used ERO method to solve the simultaneous equation.
Wow, I didn't know that ERA is useful in our life.